one for multiplying and one for dividing. Because subtraction is exactly the same. So we're going to do one example with multiplying rationals. And my example for multiplying rationals, you're going to see how much easier it is than addition and subtraction. So let's get that all written down here. So we're going to start off with the rational pairs. X plus 2 over x minus 3 times x plus 1 times x minus 3 over x minus 1 times x squared minus 4.
For the iPad, can you zoom in just a tiny bit for me? I can't zoom in on my end. That's better, thank you.
Okay. So the first thing that we're going to do, step 1, just like on the addition, was see if anything can factor. Because we want all of our factors as broken down as possible. And that's another reason we practiced all that factoring last week. So when I look at it, everything is an x. I got an x, an x, an x, an x, an x, until I get here, then I have an x squared. So that's the thing I'm going to try to factor, the thing with the x squared. And I'm going to think about that for a second and bring it over here. X squared minus 4. If I tried to factor that, I'd need an x in each one. And I need a number I can multiply to give me 4 and subtract to give me nothing. Do you remember what those were from last week? That was 2 and 2. So we need a positive 2 and a negative 2. So our next step is going to be to rewrite our fractions combining all of our terms. What that means then is this part is still going to be x plus 2. And then there's no difference between this times sign and the times in between these fractions over here. So we just need to write them all together. X plus 1, x minus 3. We're just multiplying, so it doesn't matter whether I write it like that or write it the other way. Then I'm going to write my bottom, my denominator, if you will, exactly the same. I'm going to write my x plus 3, then I'm going to write my x minus 1. And now instead of writing this x squared minus 4, I'm going to write in the 2 terms that give me that. X plus 2 and x minus 2.
Oh,
So
I'm excited.
I know, I will, me too. So now, I've rewritten the whole thing. Now we get to do my favorite part, which is reduce the common terms or the common factors.
I should put a little happy face by that, because if I was using our other video camera, I would have. Yep, right there.
Okay? So what that means is I look at the top. Once I'm multiplying, and we can only do this for multiplying and dividing. We can't do it for addition, remember, until we're all at the very end. But for multiplying right now, I can just look at the top and say, is there anything on the top that exactly matches anything on the bottom? Well, I think I have an x plus 2 right here, and it looks like I have an x plus 2 right there. So I can literally cancel those out. I don't even have to ever write them again. This is when it gets to be my favorite part. I love canceling stuff out. And I look at the top again, I don't have an x plus 1 on the bottom. I have an x minus 1, but this is not a match. That's like back in the memory game days.
Yes.
You had like the tennis shoe and the high top, and you couldn't match them both up because they weren't exactly the same.
Well, they're not the same.
And I have an x minus 3 here, and an x minus 3 there, so I can cancel those out. And then I just rewrite it with what's left over. So if I was rewriting what's left, I have an x plus 1 on the top. And on the bottom, I have x minus 1 and x minus 2. And we are done. You like that one better?
Why doesn't she speak in a French accent?
I'm not.
I know, you should. We always go Russian.
We always go with whatever comes out.
I think you should bring back
How many
Texan.
people like that one better? a lot better.
I see double hands up.
So much less wear. Alright, let's do one new take for the last example then.